Hello everyone. Today we're talking about fractional distance on both a number line and a coordinate plane. You'll find that it's very similar to the midpoint formula, just a slight addition to it. The general idea here being that if the coordinates of the endpoints of a segment are x1 and x2, and the point is m over n of the distance from x1 to x2, then the coordinate of the point is x1 plus m times the absolute value of x2 minus x1 over n. And folks, I know that's a lot in there, but let's take a look at what's that actually saying. The coordinate point there is whatever the initial point was plus the fraction of whatever the full distance is. Here's our distance formula of a line, folks. Which means we can actually make it a little simpler. This is the method I prefer. The fraction m over n can be represented as k, such that the coordinates of the point is actually the initial point, x1, plus whatever the fractional value is, multiplied by the distance between the 2 points. Whereas in a coordinate plane, we have the same sort of general idea, except now we're looking at distance with regard to the x values and the y values. And again, folks, I don't like the m over n bits. I prefer to have as few letters as possible in my equations, so I'm going to go with our k functions, k values, such that in a two-dimensional plane, our fractional value is the initial value plus the fraction times the total distance, and then the y value plus the fraction times the total distance. Now folks, for this sort of assignment lesson, there is a lot of writing. And if I were to write out everything piece by piece live for y'all, it would take quite a while. So instead what I'll be doing is I'll periodically pausing the video, writing things out, and then continuing from there. Of course, if you have questions, folks, please shoot me that email, ask the question in class, let me know, come to tutoring, so on and so forth. So, example 1. We want to find the coordinates of a point 1/3 of the distance from A to B. Well, A is located at -5, B is located at 2. We have this one line going, so we're going to use our locating points on a number line. I'm going to use version 2. So we have our x1 value and our x2 value of x1 equals -5, x2 equals 2. We have our equation x1 plus k times the absolute value of x2 minus x1. We plug in our known values. Folks, remember, when we subtract a negative, that's the same as adding a positive. So 2 minus -5 gives us 7. So we plug in our values, we simplify, we get -5 plus 1/3 of 7, -5 plus 7 over 3, which equals approximately 2.7. All right, let's take a look at example 2. We want to find the coordinates of P, a point 1/4 the distance from A to B, with our A value being -2, -4, and our B value being 4, 3. Now folks, real quick, when we do two-dimensional things, we do need to make a pre-check. What I mean by the pre-check, sketch the 2 points that you have. So -2, -4, -2, -4 down there. They don't have to be accurate, just a sketch. And then 4 and 3, about there. Notice folks, this line here is going to have a positive slope. If we have a positive slope, we can use our equation as is. If we have a negative slope, like you'll see in one of the further practice problems, we have to change the equation slightly. But I'll explain more when we get there, and I will be putting up a table in the resources page for y'all to just use to verify things. So, let's set up our equation. So we have our equation here in black with our initial point plus the fractional difference of our x values, comma, our initial y point plus the fractional distance of our y distance. We plug in our known points in red. We start to simplify in blue. Remember, folks, when we have a negative minus being subtracted, that's the same as adding a positive. So 4 minus negative 2, that's the same as 6. 3 minus negative 4, it's the same as 7. Purple, we simplify further. And here in orange, we have our final answer. Our p-value would be at negative 1/2, comma, negative 2 1/4. Let's take a look at some practice problems, some additional practice problems, and I'm going to show you a little trick here. So, with 1 through 6, we want to use the number line to find the coordinate of the point, the given fractional distance from A to B. So we're going to use this same setup for each of our problems here. By that same token, the only thing that's going to change, because our only thing that changes here are our fractional k values. Our initial x value stays the same at -9, and the distance between them stays the same at, what is that, -9 to 8 at 17, yeah? So, if we take a look at this, we take a look at our initial equation, well, our x sub 1 is always going to be -9, and the distance here, x sub 2 minus x sub 1, absolute value thereof, is always going to be 17. The only thing that changes, folks, is our k value. So I'm going to show a shortcut here. If we have this situation where we're using the same number line and the same points, such that we have the same distance overall, we can actually turn this into an equation of a line, such that we have our initial value, our x1 of -9, plus our unknown value k, let's clean up that k, times 17. Let's make that neater though, and let's replace that k with an x value. Well, now we have 17x minus 9. So now if we use 17x minus 9, where our x value here is whatever these fractional points become, we can save ourselves a bit of writing. So, for instance, if I plug this in, if I plug in 1/5 into this x, 17 times 1/5 minus 9, that should give me about negative 5.6. If I do 1/3, 17 times 1/3 minus 9, well, that's going to give me about negative 3 1/3. If I do 2/3 of 17 minus 9, that should give me about 2 1/3. Oop, double line. 3 or 4, well, that should give me 3 3/4. 1/4, that should give me negative 4 3/4. 2/5, that should give me minus 2.2. Now, folks, notice that I'm alternating here between decimals and fractions and mixed numbers. In general practice things, it's okay to do it either way. On a problem, it will tell you if it wants decimals or fractions. If it doesn't say either, you should assume that will come out to a whole number. Of course, folks, if you have any questions over this or the little shortcut here, please let me know. All right. Now let's take a look at the distance find P on line NM, that is the given fractional distance from N to M. There's not really a shortcut here, folks. We're going to have to show all the work and do all the equations and changes. So once more, folks, I'm going to pause real quick, write things out, and then I'll explain it. So here in black, we have our full equation of our initial point plus the fractional distance along our x's, comma, our initial y point plus the fractional distance of our y values. And I'm doing this version, folks, one, because I like our k's to be simple, and two, I checked the points of -3, 2 and 1, 1. We have a positive slope, so we don't need to change the equation at all. Next here in red, I plugged in the values we had. -3 plus 1/5, absolute value of 1 minus -3, comma, -2 plus 1/5 times the absolute value of 1 minus a -2. Remember, folks, when we are subtracting negative numbers, that's the same as adding a positive. So in blue, we then have 3 plus 1/5 times the absolute value of 4, comma, -2 plus 1/5, the absolute value of 3. Or in purple, -3 plus 4/5, comma, -2 plus 3/5. Now, folks, I didn't want to convert the whole numbers into fractions, so I just plugged this into my basic calculator that you guys should have access to on your practice assignments. Gave me decimal points, and that's okay for what we're doing here. Such that the point that is 1/5 the distance between N and M is -2.2, comma, -1.4. All right, let's take a look at the next one. Number 8. We want to figure out what is a point 1/3 the distance between N, located at -2, -4, and M, 4, 4. Now, real quick, folks, I'll do this with y'all. I'm going to show you the sketch I'll make. -2, -4 puts us down there-ish. 4, 4 puts us there-ish. Now, folks, take a look. Between those 2 points, we basically have a positive slope, which means we will use our initial equation without any alterations to it. So, once more, folks, here in black, we have our initial equation of our initial x plus the fractional distance of the full x's, our y plus the fractional distance of our y's. So, in red, we're plugging in our values. In blue, we're simplifying. In purple, we're combining. In orange, we're solving. Remember, folks, subtracting a negative is the same as adding a positive. So 4 minus a -2, positive 6. 4 minus a -4, positive 8. Now, folks, for these two problems so far, it's made sense in the sense that we have our midpoints being somewhere along this line. Because our equation says we're going to take our initial value, our x and y, we're going to go over some fractional distance, and then we're going to go up some fractional distance, such that our point here is going to be somewhere there-ish on that line. Same sort of thing previously. Here, we have a positive slope, and so we use the version of our equation that's going to add values to our x values and add values to our y values. But in number 9, things are going to change slightly. We want 2/3 the distance between N and M. If I sketch them out real quick, our y and our x, our N value, -7, 3-ish, and then 5, positive 2, 5, positive 2. What you should see is that even though we're going to the left a good distance, we're actually dropping a little bit. A slight negative because this 3 here is greater than this 2. Which means when we talk about our equation for this line, we still want to be able to add values to our initial x value to move our x value the, right? But we are dropping our y value. So we're not going to add to our y value, we're going to subtract from our y value. That's going to change our equation slightly, but not by too much. So we are still going to have our initial point of x plus the fractional distance of the distance between them, so x2 minus x1. We're still going to have that comma. We're still going to have that y value, x sub 1, but now, instead of that plus sign, we're going to subtract it, because we're going to drop down some values. The rest of the equation, though, stays the same. We're subtracting the fractional value of the distance, y2 minus y1. All right, once more, folks, I'll pause, finish off the problem, and then come back and explain it. All right, so fully drawn out and explained. So once more, folks, our initial equation is in black. Keep in mind that because we're going down, we have a negative slope here, we're going to be subtracting the fractional distance from our y's. Otherwise, everything works out exactly the same. We're still going to plug in our values. We're still going to remember that when we subtract a negative number, that's the same as adding a positive, such that in blue we have negative 7 plus 2/3 the distance of 12, minus, 3 minus 2/3 the distance of absolute value of negative 1. And folks, the absolute value of any negative number is itself a positive number. So in purple, we have negative 7 plus 24 over 3. 24 over 3, that's the same as 8. So negative 7 plus 8 gives us 1. And then in purple, well, from blue we have the absolute value of negative 1. Absolute value of negative 1 is 1. 1 times 2/3 is just 2/3. So in purple, 3 minus 2/3 gives us 2 1/3, such that the point 1 2/3 is 2/3 the distance between n and m. Of course, folks, if you have any questions, please ask in class. Send me an email, come to tutoring. And remember, folks, to take a look at our slopes and our directions so we know how to alter our equations as needed.